Welcome back. Today we're going to look at the quadratic formula. And you probably already have seen it before, but it is one of the ways to solve quadratic equations. So the quadratic formula actually comes from completing the square. And here it is, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we look at the quadratic formula, again, we're trying to find those solutions. We're trying to see when does the parabola touch the x-axis, or if you're solving for a certain line, you're saying when does this parabola equal 3? Okay, so that's what we're trying to solve. And so there's always going to be three scenarios. And so the three scenarios is you may have two real, and I should say distinct solutions. So you're going to have two different real numbers. So here you can see that this parabola has two x-intercepts, -2 and 1. You may have one real solution, and that's really a double root. And so we're saying here the parabola touches the x-axis at x equals 2, and that's a double root. Or the parabola may never touch the x-axis and have two, and we know this will be two imaginary roots, and they're distinct as well. So we'll have two imaginary roots, or you could say non-real solutions. Okay, so whenever we want to use the quadratic formula, we first need to make sure this equals 0. All right, so that's a really important part. Just make sure this equals 0 before you solve. And then we're going to identify the values for a, b, and c. And remember, the equation in standard form is ax squared plus bx equals c. So the value for a is 3. The value for b is -4, and the value for c is -9. And we're going to plug that into the quadratic formula. So that's -b plus or minus the square root of b squared minus 4ac all over 2a. So here we have b is -4, so this will be 4 plus or minus, and then -4 squared is 16, and then we'll have -4 times 3, let me just scooch this aside, times -9, all over 2 times 3. Now, we use the quadratic formula, and the rest of the problem is simplifying this radical. So we're going to have 4 plus or minus, inside the radical is going to be 16, and then 4 times 3, 27. So this is going to be 124 inside the radical, and this will be 6. 124 can break apart. 4 can go into 124. So this is going to be 4 plus or minus, and we know 4 times 31 makes 124. So this 4, well, we could take the square root of that, and that'll just be 2 times the square root of 31 over 6. And then the last step is looking at all these numbers, and we could tell that 4, 2, and 6 are even, and so we can reduce them by 2. So 2, really dividing everything by 2, plus or minus the square root of 31 over 3. So again, you're going to have two distinct real roots. They are irrational because you have the square root of 31. All right, let's go to the next one. So again, this equals 0. So we know that we can set this apart. So we can use the quadratic formula. A is going to equal 1. B is equal to -9. C equals 27. So plugging that into the quadratic formula, we have 9 plus or minus 81, -9 squared is 81, minus 4 times A, which is 1, and C is 27, all over 2 times 1. So let's simplify this. Inside the radical, we'll have 81 minus 108 over 2, and we can simplify that radical, so it's -27 over 2. Now we know that the -27, well, I'm going to split this apart so we can kind of see. We know that there's a -1, right? So that's going to become the I. We also know we could break apart 27 into 9 times 3. So what's going to happen is that 9 is going to come out. So the square root of 9 is 3. The square root of negative 1 is I. And then you'll have root 3 over 2. Now looking at those numbers 9, 3, and 2, there's no common factor for all three of them. So your answer is just going to be 9 plus or minus the square root, or I should say 3i, root 3 over 2. Okay, so that has two imaginary roots. So you can see it has the I, so this is 2 imaginary. And you can say solutions, roots, x-intercepts, versus the one that was for part A, well, that had 2 real roots. And I'll write solutions because I wrote solutions as well, but you can say solutions, x-intercepts, or roots. Okay, all right, so let's go to the next problem. Whenever we have a quadratic, remember there are 3 major ways to solve them. You can factor, which we've been doing a lot of. So you can factor it and then solve. You can complete the square, which we practiced last week, or you can use the quadratic formula. So whenever you have a quadratic equation, you can choose your method. So looking at this quadratic equation, we can see that this has a 6. And so remember, when we wanted to complete the square, we wanted to have x or a equals 1. And right here, a equals 6. So we probably don't want to complete the square, even though you can, because you have an odd number in here, and we know we're going to have to divide by 6, and then we're going to have to divide by 2, and then square it. So let's try to factor it first. Remember, we first need to look at a and c, which is -6 and -20, and we want 2 numbers that multiply to make, that'd be -126 times 20 is -20 is -120, and we want them to add to equal -7. So 2 factors of -20 that add up to equal -7 are -15 and 8. So what I'm going to do is split apart this -7, so use decomposition, and we're going to make that 6x squared minus 15x plus 8x minus 20 equals 0. And now we can use grouping. So looking at those first 2 terms, well, they both share a 3 and an x. So I can factor out the 3x, and we'll have 2x minus 5. Looking at the next 2 terms, well, they both are multiples of 4. So when I divide them by 4, we get 2x minus 5. And that's what we want. Remember, we want to have a common factor. So 2x minus 5 can factor out, and we have 3x plus 4 as our second quadratic factor. So in factoring, we're going to set each of these factors equal to 0. And when we set them equal to 0, we can solve for x. So the first one will equal, this will be 5 over 2, or 5 halves. And the next one will be -4/3. So we have 2 real distinct answers. All right, perfect. All right, the second method, and remember we opted not to complete the square. Well, we could use the quadratic formula. So when we use the quadratic formula, remember we still need to identify a, b, and c. So a in this problem equals 6, b equals -7, and c equals -20. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. So when we plug that in, we have, that'll be +7. -7 times -7 is 49. Minus 4 times 6 times -20. That's our a and our c. All over 2 times 6. All right, and then the rest of the problem is just simplifying. So 7 plus or minus, we'll have 49 plus 480 over 12. And we can simplify that radical a little bit more, because that will equal 529 over 12. So we know we're going to get 2 answers, because the square root of 529 is 23. So we'll have 7 plus 23 over 12 and 7 minus 23 over 12. So let's just simplify this. This will be 30 over 12, and 6 goes into both of those, so that's going to be 5 halves. And then for the next answer, well, that equals negative 16 over 12. Well, 4 goes into both of those, so we'll have negative 4 over 3. And that's exactly what we got when we factored the problem as well. So you can choose your method when you're solving the quadratic equations, but just like we said, we didn't complete the square. That was the third method, but you can choose whichever method works best for you. So completing the square probably wasn't going to be the fastest or most effective. All right, now let's go back to looking at these. So for this example, we wanted to make sure we used the quadratic formula to determine the roots, and then to see what's happening with these equations. So when we look at this, we could see that the first one, 2x squared minus 7x plus 3. Well, that one touches the x-axis 2 times right here. And so it's going to have 2 real roots. And we can use the quadratic formula to find them, right? So we get 7 plus or minus 5 over 2. And we could simplify that a little bit more. So I'll simplify it over here on this side. So I'll have 7 plus 5 over 4 and 7 minus 5 over 4. All right, so 7 plus 5 is just 12. This will be 3. And then negative 2 or negative 1/2. And we can go back to this graph and see really quickly. So you can see right here, here's 3, and then here's that 1/2. So it has 2 distinct roots. And then this part, the same problem, but the second part, we have the equation 4x squared plus 12x plus 9. Using the quadratic formula, we can find the roots, but looking at the graph, you can tell there's going to be one double root. And so to simplify that, you would get x equals negative 12 over 8. 4 goes into both of those numbers. So that's really negative 3 over 2, or negative 1.5. And you can see that right here, that x is negative 1.5, which is also negative 1.5. So when it has one root, one double root, it'll just touch the graph once. And then for the third one, we have the parabola here, and you can tell that the parabola is not going to touch the graph at all. So it's going to definitely have 2 imaginary roots. And when we plug it into the quadratic formula, you can definitely see that you'll get 2 imaginary roots, negative 1 plus or minus I root 7. So when we look at that square root, so looking at these numbers here, the square root, it's also called the discriminant, tells us what kind of answer we're going to get. So if it's 25, if it's a positive number, we're going to get 2 real distinct roots. And we can say, let me put here, 2 real, and I'll put distinct because they're 2 different solutions. You could say roots, zeros, or solutions. And again, we're looking at what's inside that square root, b squared minus 4ac. If that square root, or that discriminant equals 0, then we're going to have one double root, one double real root or solution. And you can tell on the graph it touches the x-axis once. And then if the discriminant is less than 0, is negative, and in this problem it was negative 28, well, that means we're going to have 2 distinct, 2 different imaginary solutions. It means that we can't have anything that really happens. All right, it's never going to really touch the x-axis. So this example asks us to interpret the discriminant. When we consider the equation, we're going to set that equation equal to 4. So we're saying, will it reach a height? Because h of t represents the height. So we're saying, does this equation, will there ever be a time where this reaches or equals 4 feet? Or 4 meters, I should say, not feet. All right, so what I need to make sure we do is set this equal to 0. Before we can use the quadratic formula, we always need to set this equal to 0. So when I subtract 4 from both sides, we get -2. So negative 5t squared minus 5t minus 2 equals 0. So remember, we're looking at the discriminant, which is b squared minus 4ac. So let's first identify those values. So a in this equation is -5, b is also -5, and the c, right here, is -2. So let's plug that in. So b squared minus 4ac, so -5 squared minus 4 times -5 times -2. Well, that's 25 minus, that'll be 20, -40. And we know when we add those together, it'll be -15. -15 is less than 0. So that means we're going to have 2 imaginary roots, right? So it's going to be 2 distinct, you could say distinct, but 2 imaginary roots. So if something has 2 imaginary solutions or roots, remember, it's not going to happen. It's not going to touch the x-intercept. It's not going to really happen. So this is not going to occur. She will not, or the tennis ball will never reach 4 meters because they only get imaginary solutions. So we know that it will not reach the 4 meters. Now, if we're given a parabola, but we're missing one of the variables, so we're missing the coefficient b, and we have to figure out what's that going to equal to have one real solution, well, we know that means that b squared minus 4ac has to equal 0, because the square root of 0 is just 0. So we need to have that equal to 0 to have one real solution. So let's just identify all these variables. So a equals 2. Well, b we don't know. That's what we're solving for. And then c equals 18. When we plug those into the discriminant, we'll have b squared minus 4 times 2 times 18 equals 0. This will equal 144. Well, you have a couple ways you can solve this, right? I'm going to show both. But one way is to add the 144. And now you can take the square root of both sides. So you have b squared equals plus or minus, sorry, that'll be just b, plus or minus 12. Or we can factor this. So we can actually go from this step up here and we can say, well, that's going to factor into b plus 12, b minus 12 equals 0. And then just like you did before, you just set each of these factors equal to 0 and you would get b equals plus or minus 12 again. All right, so either way, either using the square root or the factor. You don't have to do both. But we know that if we want to have one real solution, well, there's 2 possible answers for b. You could have 2 equations. You could have 2x squared minus 12x plus 18, or you could have 2x squared plus 12x plus 18. And both of those parabolas will have one real solution. So again, going over this lesson, there's 2 major parts here. The first was the quadratic formula. So we know we could use the quadratic formula to solve quadratic equations. And then the second part of this lesson was looking at the discriminant. What's inside that square root, b squared minus 4ac. And that discriminant can tell us if we're going to have 2 real solutions, 1 real solution, or 2 imaginary solutions. Well, I hope this lesson was helpful, and I'll see you all in class.